So now we can see, just we have discussed about the batteries. So what is battery? Now this is just a mind map, and this is the revision tools. And by this, the revision tools using mind map, you can see at a glance. Means it's a revision tools. Okay, already we have discussed. Now we go through the whole concept in one page only, so that in exam when you go through by this mind map, you can recall everything whatever you have studied in detail. So what is battery? The whole things of battery just sum up in mind map. What is battery? Yes, it is a group of cells which are connected in series. And what is the principle of battery? It is based on galvanic cell. That means chemical energy convert into electrical energy. What are the two types of battery? Primary. What is primary battery? In which the reaction occurs only once and cannot be recharged or reused. And what are the two examples we have discussed? Dry cell, which is also called Leclanche cell. And second is mercury cell, that is called button cell. Right. So battery are two types. One is a primary, in which two examples, dry cells and mercury cells. Secondary battery, which can be reused by recharging. And the examples are nickel cadmium and lead storage. And one example we have discussed, fuel cell. Now, what is dry cell? You have seen, this is a diagram of the dry cell. Anode is made up of what? Zinc. Cathode is made up of carbon with MnO2 powder. Electrolyte used, ammonium chloride and zinc chloride paste. Potential, cell potential, 1.25 to 1.5 volt. Cell reaction, anode reaction is what? Zinc 2 plus by loss of 2 electrons. Cathode, this MnO2 powder reduced in presence of ammonium electrolyte to form MnOOH plus ammonia plus water, and then add both equations by multiplying to cancel out the electrons. So what is overall reaction by adding both anode and cathode? Zinc plus MnO2 plus ammonium to form zinc 2 plus MnOH, ammonia plus water. And already I've told the zinc 2 plus ion, which is formed at anode, and ammonia, which is formed at cathode, they also combine to form zinc tetraammonia zinc complex, which is soluble. Where is the use of the dry cell? Use in what? Toys, remote battery, torch, remote control, and so many other places. What is the advantage of this dry cell? It can be carried out anywhere, and dry cell even do not use for the long time. It become corroid or it can become discharged because ammonium chloride, which is acidic in nature, which corrode the zinc container, even if the cell is not in use. Right? Now moving to the second cell, that is mercury cell, which is also called button cell. Okay, anode is made up of what? Zinc amalgam. Cathode is made up of what? Cathode is made up of paste of HGO and carbon. What is electrolyte used? The paste of QH and zinc oxide. Okay, so anode is zinc amalgam, cathode is HGO plus carbon, electrolyte QH plus zinc oxide, and the cell potential 1.35 volt. Now, what is the cell reaction? Anode, zinc, in the presence of electrolyte, that is OH minus, to oxidize into zinc oxide, plus water, plus 2 electron, means zinc converting to zinc oxide. At cathode, this mercury oxide, except water and electrons to reduce into mercury, plus OH minus. And then you add both equations, anode and cathode equation, add it. What is overall reaction? Zinc plus HGO gives zinc oxide plus Hg. So what is the advantage of this cell? It's used in the low current device like watches, hearing aids, because its potential value is low. And this cell potential remain constant it's throughout the life till it's working, because no ions are involved in the overall reactions. So concentration will remain same. Now moving to the secondary battery. Secondary battery nickel cadmium cell. First is the nickel cadmium cell. Nickel cadmium cell anode is made up of cadmium, cathode, nickel oxide, electrolyte QH, potential value 1.45. Anode reaction, cadmium convert into cadmium hydroxide in presence of electrolyte. ठीक है, cadmium से cadmium hydroxide, cathode nickel oxide, accept that electron and water to convert it to nickel hydroxide. And what is overall? Cadmium plus NiO2 plus water gives cadmium hydroxide plus nickel hydroxide. Where the use of the nickel cadmium cell, it's used in portable computer. Okay, so all the portable computer it is used. An advantage is it's longer life than lead storage battery, but the disadvantage is very expensive. Okay, now the very common secondary battery, that is lead storage battery. It is a combination of 3 to 6 series of cells. So it is a combination of 3 to 6 voltaic cells which are connected in series. Anode is made up of lead, spongy lead. Cathode is made up of PbO2 with lead grids. Electrolyte, sulfuric acid, that is 38%. Its cell potential 6 volt to 12 volt. Now there is a two type of reactions, discharging and recharging. In discharging means it behaves as electrochemical cell. So discharging at anode, this lead oxidize into lead sulfate by loss of electron. Cathode, PbO2 reduce into PbSO4. So anode lead to lead sulfate and cathode also PbO2, PbSO4 by loss of electron, by gain of electron in the presence of electrolyte. So what is the overall reaction? Pb plus PbO2 plus electrolyte, that is sulfate ion and 2 sulfate ion and 4H plus, means 2 moles of sulfuric acid to form PbSO4 plus S2, means Pb plus PbO2 in the presence of electrolyte convert into PbSO4 plus water. So this is the discharge, when it is used, that is discharge reaction. During recharge, the reaction is reverse. Means anode, okay, reaction reverse. Just you write the reverse reaction. Anode ka reaction reverse likho. Means PbSO4 plus 2 electrons gives Pb plus SO4. Anode ka jo bhi reaction tha, that we have written reverse. PbSO4 plus 2 electrons give Pb plus SO4 2 minus. So anode reaction become reverse, and hence anode also become reverse. Means anode become cathode and cathode become anode. So reaction will be reverse and electrode also become reverse. And then you write the overall also become reverse. So whatever the overall reaction was there, you see it is just reverse. 2 PbSO4 plus 2S2 gives Pb plus PbO2 plus sulfate ion plus 4H plus. And where is the use of this lead storage battery? Yeah, already we have discussed so many times that use in the automobiles, that is car battery, inverters, and so on. So this is a very good tools by which you can easily learn at one place, at one glance, that is a primary battery and secondary battery. Now the second example is, the last example is fuel cell. Fuel cell principle is also based on galvanic cell. Means convert chemical energy to electrical energy. So we'll discuss one example that we have already discussed, again revising hydrogen oxygen fuel cell. Okay, now come to the electrodes. Both anode and cathode are made up of carbon rod and incorporated with platinum powder to increase the surface area. Electrolyte, aqueous NaOH or QH. Now, what is a cell reaction? At anode, hydrogen gas. At anode, we supply hydrogen. So hydrogen get oxidized into water. So this is reaction. H2 plus 2H minus gives 2S2 plus 2 electrons. Cathode, O2 reduced by gaining this electron and water to form OH minus. And the overall reaction is 2H2 plus O2 gives 2H2. So where is the use of the fuel cell? The fuel cell used in Apollo space program to provide electricity and water to the astronaut for drinking purpose. And very advantage of this fuel cell is it is eco-friendly. Means it is free from any pollution because water formed as a byproduct and water is not harmful product. Cell works until S2O2 being supplied at this temperature and pressure. The next advantage is its efficiency is very high, that is 70%, while other thermal power plants having 40%. And the raw materials, hydrogen and oxygen, which are also not expensive. That is a cheap raw material. Okay, so use this mind map. I will share this mind map in the chat box also, so you can revise from there.